So a couple examples here on page 424 ask you to state the domain and range of these particular functions. So for this one over here, let's look at the domain first. If we imagine that there's a bunch of points all the way down here, and that we're tracing those points back to the x-axis, a lot of these points, all of these points will get hit. And same if you trace these ones down to the x-axis. But because of this arrow, we know that this is going to go on forever to the left, and forever to the right. So not only are these points on the x-axis all going to get hit, but everything is going to get hit forever to the left and forever to the right. So the way we would write that is the domain is everything, or x is an element of the reals. Don't worry about that double R, it's just a habit I had because some textbooks use that format, but you don't have to if you don't want to. So there's our domain. Everything on the x-axis will get hit. But if we highlight the y-axis, let's see what happens. There's a bunch of points here on the graph, and we can see where they might hit the y-axis. So they're going to all hit here, here, here. So it does seem that a lot of points are going to get hit on the y-axis. In fact, everything upwards from here is going to get hit. But don't forget down here, this one maps to the y-axis as well. So if you imagine all the values on the y-axis that will get hit, it is everything from -3 and upwards. So if we're looking at the range, we can say that all the y values get hit if they're bigger or equal to -3. And then we do put curly brackets around that. Over here, we have a different example. We have a circle or an oval. So we're mapping this back to the x-axis. Let's look at these bounds. So this is 4, and this is -2. So all the x values between -2 and 4 will get hit. Some of them will get hit twice. So we would say that the domain has to be between -2 and 4. So all the x values live between -2 and 4. But other than that, it's continuous, and that's why we put this x to the element of the reals here. We use that for continuous functions or relations. And if we look at the y-axis, so this is 1, and this is -3. So the y values are actually running between -3 and 1. So we'll put that there. And this is also continuous. So we'll put y as an element of the reals. So everything in between those values will get hit. We're still looking for the domain and range, but this is actually a mapping diagram. So here are our x values over here, and here's our y values over here. So this one's actually not too bad because there's only 3 x values that get hit. So the easiest way to express that is simply to list them. We do not put that x is an element of the reals because it's not a continuous function. Only the 3 points get hit, nothing in between. Same with the range. It's just 2 and 6. So when it's discrete like that, you can simply list the points. This one asks for the domain and range, but it doesn't give us the diagram. It only gives us some clues. So the only way to really know this is if we actually draw the circle they're describing. So a circle has a center -2, 3. And it has a radius of 3, which means it's going to go out by 3 units on every side. So if I kind of just give a rough sketch of the circle here, here are the boundary points of that circle. So when I'm looking for my domain, we're looking at the values of x that run between these 2 points here. Okay, so we're looking at -5 all the way to 1. So our domain is -5 to 1, and it's x values that run in between those. And it is a continuous function, so we put that x as an element of the reals, and then the curly brackets. And then for the range, we just have to look at the lower and the upper bounds of the y values, and they are all here. So we're actually going from 0 to 6. So y lives between 0 and 6, and it is continuous. So let's put that. And there is our range. We are still on page 424, but this question actually asks us to draw the relation that has these restrictions on it, which is interesting. So it says draw the graph of a relation which has this domain, which is x as an element of the reals. So we will draw this domain. That means everything. So it has all the values of x are going to get hit. And then it has this particular range. Y is less than or equal to 2. Now, a lot of students get thrown off by this. What does this y bar mean? So this means y such that. But it's kind of optional for your purposes. It means the same thing as this. You don't have to write it, but it just says y such that and then these restrictions on it. So it's just another way of writing the range, but it means the same thing as this. So they want us to draw a graph that hits all the values of x, but only hits the values of y that are 2 or less. And it only is allowing us to have one x-intercept over here, so not 2. It doesn't tell us where the x-intercept is supposed to be, so it doesn't actually matter where you put the x-intercept. Like, I could put it here, and then I could draw a graph that hits everything below that. But the problem with this graph is that it doesn't actually hit all of my x values over here. So this is not the graph that we're looking for. The problem is, if I extend it all the way over on this side, the blue side, I'm going to end up with 2 x-intercepts. So really, this should be the answer to this question over here. The one with 2 x-intercepts, I can draw this. It's going to go on forever that way. And then this, and it'll go on forever that way. And we don't get any values on the y-axis above 2. So that one's good. This one's no good. We got to think again. What is a way that I can generate only one x-intercept, but it actually goes and hits all the values? Well, there are many ways to think about this, but maybe one thing that we can do is we can simply send it off this way, and then we can also send it off this way. So we can do it like that. I know it's not connected, but it doesn't say that it has to be connected. It just says a relation, right? So this is a perfectly acceptable solution to something like this. What's worth noting is that there are a lot of correct answers to this particular question, but there are also a lot of incorrect answers. So for example, what if I did one that didn't quite connect? What if I did it like this? Would that meet the requirements of the question? Well, because of these arrows are pointing down, we are eventually going to hit all of the y values going down like this. But take a look at this. These x values in between here that we were supposed to hit, because we were supposed to hit everything, didn't get hit. So that's why you can't draw it in that particular way. What if we drew it like this? Would this be acceptable? Well, yes, all of these x values are getting hit, and all of these x values are getting hit. But what about the y values? This one doesn't point downwards, it points horizontal. However, I think that because this one points downwards, I think we are covering our bases because everything downwards from here is going to get hit on the y-axis by this branch of the graph. So this graph is also an acceptable solution, whether you decide to put this one on a tilt or not. But it's an interesting question to think about what solutions are acceptable and which ones do not meet the restriction. We are still on page 424. This question asks us to explain why it is not possible to draw a graph which has the domain of x element of the reals, which means everything, and also has a range of y less than or equal to 2. But this one has no x-intercepts at all. So they want us to hit all the values of x, and they want us to hit everything that is 2 or lower on the y-axis. But they don't actually want us to cross the x-intercept line. So if I want to hit 2 here, y less than or equal to 2, I need to hit everything down here. Now whether I take this path, or a curved path, it doesn't matter what path I take, they all are going to cross the x-axis here. They all have x-intercepts. There's no possible way that you can actually hit all the values less than or equal to 2 and not touch the x-intercepts. And I think this diagram indicates the reason for that. So what we could say is that by hitting all values, y values, less than 2, we must hit y equals 0. So y equals 0 is somewhere along this line, which is an x-intercept. So you can't tell us to hit all the y values less than 2. That means we have to hit y equals 0, but that's an x-intercept, so we have a contradiction. And that's why this graph is impossible to draw. So this is not actually in your books, but I think that it is important to address it, which is the idea of the open versus closed dot endpoint. So for example, if I were to create a graph that looks like this, and I put a hard solid dot on the end of it, that means that that value is included in my domain. So my domain of this particular graph would be, well, it starts at 2 and then goes on forever. So I would say that x has to be greater or equal to 2, and it is continuous, so I would put that. But if I draw a different graph that's almost the same, but I use the open dot, that means that that endpoint is not included in my domain or my range. So in this case, the domain is x is greater than 2. It's not equal to 2, so I wouldn't put that equal sign, and x element of the reals. So the same goes for the range. Because it is a closed dot, this value of 3 is included. So y is less than or equal to 3. Y is an element of the reals. And that is the range of this one. Whereas the range of this one, the 3 is not included in the range. So I would say y is less than 3. Y is an element of the reals. In general, when you are drawing graphs, you should either put a solid dot, an open dot, or an arrow on that graph. So if we go back to the graphs that we were drawing in the last question, technically, we should make sure that this is a closed dot to be clear to the viewer that this is included in the domain and in the range. And then make sure that there are arrows if it does go on forever.